ይሰማችኋል? እሺ
ሚስተር
Okay. Before we start our Zoom discussion, let us introduce myself. My name is David Shfarao. I am your mathematics teacher for this grade level. I'm in for grade 8. So today we will start our discussion formally. So the first unit is all about squares, square roots, cubes, and cube roots. So today we'll discuss the point of square numbers. So now let us start. Basically, under this topic, we are going to deal 4 basic concepts: square numbers, square roots, cube numbers, and cube roots. These are the 4 basic concepts that we deal under this topic. So before we are going to define what is square numbers, first, let us say something about powers generally as an introduction. So to define power, we can define power as any expression written in the form of like this. Any expression written in this form is called as power. For this case, we can name the number written under this position is base, and the number written under this position is exponent. So any number written in this form is considered as power. So when we define what this expression means, the exponent shows how many times we multiply the base. So when we define the power expression, this one we can define as a times a times a up to n times. So the exponent shows how many times we are going to multiply the base. And we can read this expression, the above expression as a to the power of n, we can say, or a raised to n, or the n's power of a. We can read that expression in these 3 ways. We can say a to the power of n, or we can say a raised to n, or we can say the n's power of a. So simply, power means this one. So any expression in mathematics that is written in this form is considered as power. As an example, we can consider so many examples. Before we consider examples, there is a restriction. Remember, a can be any element of rational numbers. It can be any element of rational numbers. And n can be any number of natural numbers. So this is a restriction when we define a power in your level. So a can take any rational numbers and n can take any natural numbers. So as an example, we can consider so many examples. We can say like this one. This is a power. We can say this is a power, and so on. So when we read this power expression, we can say 10 to the power of 2. We can say 10 raised to 2. We can say okay. And we can say this one 5 to the power of 3 or 5 raised to 3. So you can read in both of all 3 ways. The next point, when we consider a number in standard form, some numbers have only a single power form, some have more than 1 power form. So let us see this concept with examples. Let us consider the number 64. This number is a number in standard form. So to write this number in power form, we use a factor tree to simplify our works. So let us use the factor tree. By using the factor
Let me eat my breakfast.
tree. So when we divide 64 by 2, it is 32.
Can understand so
When we write 32, divide 32 by 2, it is 16. When by 2, it is 8. By 2, it is 4. And by 2, it is 2. So after we did this work, we collect the prime factors, that means 2. So 1, 2, 3, 4, 5, 6. 2 times, 2 times, 2 times, 2 times, 2 times 2. How many times? 6 times. The factor 2 repeated 6 times. So when we write a given number in standard form as a power form, we are going to write that number as a factor of the same or identical factors, like this one. So we can say 64 can be written as a power form to the power of 6. One way of expressing 64 as a power. Or we can say 64 can be written also as 4 times 4 times 4. It's possible. The point is, we should write the given number as a product of identical factors. So 64 as a power form can be expressed as 4 cubed. This is the other way. Or also, we can say 64 is equal to 8 times 8. So again, 64 can be expressed as a power as 8 the power of 2. So 64 can be expressed as a power form in 3 ways. It can be, we can say to the power of 6, or 4 the power of 3, or 8 the power of 2. Let us add one example. If you can take the number 125, so to write in power form this number, so we can by 5, 25, by 5, 5. So 25, 125 can be written as a product of identical factor as 5 times 5 times 5. So 125 can be written as a power form as 5 the power of 3. So as you see on the example, some numbers has only a single power form, some number have more than one power forms. For this case, when we write 8 as a power form, first, when we write as a product of identical factor, it can be written as 2 times, and as a power form to the power of 3. So this form can be, when a number written in this form, considered as a standard form. This form is called standard form. And this form considered as factor form. Factor form. And this form, it is a power form. Power form. In power form, remember, the number written under this position is called the base, and under written in this position is called exponent. So generally, if we discuss this one as as an introduction for power, that's enough. I give you this the highlight of power, because square and cube are a specific case of power. That's why I raised the point before. Do you have any question on this?
No.
No.
Okay, now.
No, mister.
Okay, let us go to the main point. This is an introduction. Simply remember, a power is a number written in this form, generally in this form. So squares and cubes are squares and cubes are a specific examples of powers. So now let us go to the main point of our discussion. Okay, now let us go to the define square numbers. We can define square numbers in 3 ways. As we discussed before, we can simply say it is a power with exponent 2. We can say simply like this one. A square number is a number which is expressed in power form with exponent 2. We can say like this one. Or square number is a result or a product when a rational number has been multiplied by itself. Or a square number is a number that can be written in the form of two same or identical factors. So we can define square numbers with these three ways. Simply, we can say it is a power with exponent 2, or it is a number written in the product form with identical factors, or it is a number when we multiply a rational number by itself. So this is a square number definition. So you can define with the three ways. Now let us consider examples. Based on your text, the first square number is 1. 1 is a square number. Why? Because 1 can be written as 1 times 1, or it can be written as 1 the power of 2. The second square number is 4. 4 can be written as 2 times 2, or to the power of 2. So 4 is a square number. And the third square number is 9. 9 can be written as 3 times 3, or 3 the power of 2. And 16 is also a square number, which is equal to 16 can be written as a product form, 4 times 4, and as a power form, 4 square. So remember, the square numbers are the result, not the factor numbers. So 1, 4, 9, and 16 are square numbers. Okay, now to visualize the concept of square numbers, let us consider a square in geometry. Already you know that a square is a quadrilateral in which the same lengths and widths. So let us consider this square. Let us consider a square, this one. Let's say the length is expressed in terms of A, and the width also expressed in terms of A. So the area of a square is the product of the length and the width. So in this case, the length and the width are expressed in terms of A. So A is equal to A times A. A times A, by result, it is A the power of 2, which is equal to A times A. So from this concept, we can understand area of a square is the best example to express square numbers. Most of the time, we visualize a square number using area of a square. So for this case, the power, remember, a square is a specific case of a power, or a specific example of a power. We said this before. So this power expression can be written in 3 different ways. We can say a squared, simply we can say a squared, or we can say the square of A, or we can say A to the power of 2. So you can read square numbers within these 3 ways. You can say simply A squared, or you can say the square of A, or you can say A to the power of 2. So you can read the power with exponent 2 like this one, or a square number like this one. Okay. Now, let us go to the next point. Most of the time, students confused with 2 expressions. With these 2 expressions, the first expression, this one, A squared, and this one, twice of A. Remember, A can be any rational number. So most of students confused with these 2 expressions. Most of the time, students assume that they are similar, but they are not similar. They are completely different. The 2 expressions are different. As we defined before, A square means A times A. And
2A means, Mr. 2A means 2 times.
Not times. 2A means, twice of A means A plus A. A plus A. So the 2 expressions are different. Most of the time, students confused with the case 2. They said 2 squared is 4 and 2 times 2 is 4. So the 2 expressions are similar, but this is not true. This is not generally true. We can consider example. Let us consider the example 30 squared. 30 squared means, by definition, it is 30 times 30. and the result is 900. And twice of 30 means it is 30 plus 30, the result is 60. So the two expressions are generally different. So don't confuse with these two expressions. Okay. The last point, it's perfect squares. Perfect squares. Perfect squares are nothing, just a special name given to those square numbers. So those all square numbers can be generally by a special name considered as perfect squares. So don't confuse with square numbers and perfect squares. Some books refers square numbers, some refers perfect squares. So a rational number is called a perfect square if it is a square of some rational number. Let's say x is an element of any rational number, and if we say x is a perfect square, so that number must be written as a product of two identical factors or as a power with exponent 2, like this one. So x can be written as a product of two identical factors as this one, n times n, or it can be written as a power with exponent. So n is also, for this case, an element of rational number. So a perfect square is a special name given for those all square numbers. So if you are going to mention, if you are asked to mention perfect square numbers, you can say 0 is a perfect square because it can be written as 0 times 0, and which is equal to 0 square. 1 is a perfect square, 2 times 2, and 1 times 1, which is equal to 1 squared. 4 is a perfect square because it can be written as 2 times 2, which is equal to 2 squared. 9 is a perfect square, 3 times 3, which is equal to 3 squared, 16, and so on. 4 times 4, which is equal to 4 squared. So if they satisfied this condition, so the result, the product number will be, the result number will be a square number or perfect square. So don't confuse with the term perfect square and square numbers. They are similar. So this is all about square numbers. Do you have any questions on this?
No, mister.
No.
Is everything clear?
No.
No. Yes.
Any question?
ሚስተር
ከሌላችሁ ጠይቁ፣ አትፍሩ። ያልተገባችሁ ነገር ካለ ባወራሁት ነገር ላይ እዚህ ቦታ አልገባኝም በሉ።
ሚስተር the first square number ቢባል ምንድን ነው የምንለው? 0 ነው የምንለው ወይስ 1?
አይደለም ቤዝ አሁን ብዙ ጊዜ ጥያቄ ሲሰሩ ቤዝድ ኦን ዩር ቴክስት ነው ኢንፎርሜሽን። ናሽናል ኤግዛማችሁ ላይ የሚወጣው በቴክስታችሁ ነው። አንዳንድ ሪፈረንስ ቡክ ላይ ከዜሮ ነው the first square number ብሎ ኮንሲደር የሚያደርገው 0 ነው። ግን በእናንተ በመጻፋችሁ ስለሆነ ኤቭሪቲንግ መመለስ ያለባችሁ መጻፋችሁ the first square number ብሎ ኮንሲደር የሚያደርገው 1 ነው። ስለዚህ 1 ነው።
እሺ
መጻፋችሁ ላይ የሚሰራ ጥያቄ አለ። ከዜሮ ከጀመራችሁ አይመጣም ያ መልሱ፣ ከአንድ ከጀመራችሁ ነው የሚመጣው።
እሺ ሚስተር።
Okay, any other question? Okay, ኖትና ወርክሺት ተዘጋጅቶላችኋል። ሲተሰጣችሁ ኔክስት ታይም ወርክሺቱን አብረን እንሰራዋለን። ስኩዌር ነምበርን በዚህ ፋይናላይዝ ካደረግን ያኔ ክላስ ጀምሮ ደግሞ በደንብ ዲስከስ እናደርገዋለን ማለት ነው።
እሺ ሚስተር።
እሺ ለዛሬ በቀናል። ቻው
ቻው
Mister.
ቻው።
Okay. Hello everybody, how are you?
Hello.
Are you there? Are you listening?
Yes.
Yes.
Okay,
Yes.
let us start our discussion. For today, we will discuss about basic properties of perfect squares or square numbers.
ይሳቅ ዝም በል።
Okay. So the first property that we are going to consider for square numbers is that square numbers are invalid or are non-negatives. So the square numbers are non-negative. So by property, all values of square numbers are non-negative. To consider example, if we take the square of minus 30, so when we calculate the square of minus 30, which is equal to minus 30 times minus 30, so the result will be positive 900. So if you take any rational number and take the square of that rational number, the value will be positive. But here, there is a difference between this expression and this expression. This one is the square of negative 30, but this one is not. So when you calculate this one, you calculate like this one, which is equal to minus of the square of minus of 30 square means 30 times 30. So which is equal to, the value will be negative 900. So this expression and this one, totally they are different. So this is the first property. Square numbers are all non-negative, invalid. Is that clear?
Yes.
Okay. Okay. Second property. Let us take A, which is an element of rational number. Then let A and B. Let us take two rational number A and B, any rational number they are. So A times B square means A square times B square. So this is another basic property. If you consider an example, 2 times 3 square means, which is equal to 2 square times 3 square. So which is equal to 4 times 9, which is equal to 36. Again, you can calculate like this one. 2 times 3 square means 2 times 3 is 6. So 6 square, which is equal to 36. So the property holds true. We can prove the property by counter example like this. Again, A over B square means, which is equal to A square over B square. So to consider an example for this case, let us take 4 over 5 square, which is equal to 4 square over 5 square, which is equal to 16 over 25. So this is the second basic property. And the third one, before we go to the third one, is there any question on this, the first and second property?
No.
No.
Okay. The third property, the units digit of all square numbers. Square numbers are in this with 0 or 1 or 4 or 5 or 6 or 9. So when you check out all square numbers, their units digit in this with 0 or 1 or 4 or 5 or 6 or 9. You can check it this one. Let us consider example for this case. Let us start from the first, or based on your circuits, the first square number is 1, but we can start from 0. 0 is a square number. Yes, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. You can check all the square numbers. If you see the units on these numbers, it in this 0 or 1 or 4 or 5 or 6 or 9. Is that clear?
Yes.
Yes.
Okay. Now let me give you one exercise, and I'll give you time to do that. Okay. The question is, if 17xy is equal to 22xy minus 5, then what is the value of x squared y squared? Let me give you 5 minutes, try this question, and you will tell me your answer. Are you trying?
Yes.
Yes.
Yes, mister.
Okay. So what is the value of x square y square? 1. Any other answer?
1.
Okay. Let us do together. So we are a given condition that 17 xy is equal to 22 xy minus 5. Let us start from this given condition. So when we shift this expression to this side, we will have 17 xy minus 22 xy is equal to minus 5. So minus 17 xy and 22 xy are like terms, they can be subtracted. So it will be minus 5 xy, which is equal to minus 5. So when we divide both sides of the equation by minus 5 over minus 5, so minus 5 cancel out by minus 5. So what is left? X times y. So negative by negative, by 5 1 by 5 1 is equal to 1. So x times y is equal to 1. So but we are asked what is the value of x square y square. So we take the square of the equation on both sides. So when we square the equation on both sides, we will get x square is equal to 1 square. So x square y square by the property, it means x square times y square, which is equal to 1 square means 1. So the value of x square times y square is equal to 1. You are right. Okay, so these are the 3 basic properties of a square. You can add by your own. There are so many properties. Now let's back to the worksheet questions. Do you have any question on the worksheet?
ሚስተር ድምፁን በደምብ ጨምሮ አይሰማም።
ኦኬ ወርክሽቱ ላይ ጥያቄዎች አላችሁ? ወርክሽቱ ደርሷችኋል?
አዎ ሚስተር።
ጥያቄ ያላችሁ ወርክሽቱ ላይ?
አዎ።
ኦኬ let us see that one. ስንተኛው ጥያቄ ነው? ኦኬ ስንተኛው ጥያቄ ነው ጥያቄያችሁ?
የቹዙን አምስተኛውን ሚስተር።
ኦኬ
is not a square rational number ይላል ግን
ጥያቄ የሚለው which one of the following is not a square of a rational number ይላል። yes so what is the problem on this question?
there is no problem, but they're all rational numbers.
No, the question says which one of the following is not a square of a rational number. If we take A, it is 81. Is that not?
Yes.
So 81 means 9 square.
9 times 9.
9 times 9 or 9 square. So it is a square of a rational number.
Yes.
What about B? B, if we take 225, it is 15 square. 15 times 15. It is a square of a rational number. And C, if we take C, which is 625, which is 25 square, 25 times 25. But D, 160. Is it a square number first? Is there any rational number when we multiply that rational number by that gives 160?
No.
No. So the answer is this one, D. ገብቷችኋል? Okay, any other question? ሌላ ጥያቄ የላችሁ?
የለንም።
የለንም ሚስተር።
Okay. So next time square root እናያለን። ለዛሬ በዚህ በቀናል።
እሺ
ቻው ቻው።
ኖት የወሰድነው ነው እንዴ? በዛው የምንቀጥለው።
Thank you, Mr. Chow.
ሚስተር ወርክሺት እናስረክባለን።
አይ ወርክሺቱን ፕራክቲስ ታደርጉታላችሁ። ኤኒ ኩዌሽን ካላችሁ ልክ እንደዚህ ዲስከስ እናደርጋለን።
እሺ
እሺ ሚስተር ቴንክ ዩ ቻው።
ቴንክ ዩ ሚስተር ቻው። ለሁላችሁ መልካም ቀን ይሁንላችሁ።
ብሩ
ቻው።
አተሳሚ ኦንላይን ግባ። አቶ ኦንላይን ግባ።
አዲዮስ አሚጎስ።